Okay, so now we are going to talk about density clustering on the algorithm of DBSCAN, which is a clustering algorithm based on density of the data. DBSCAN stands for Density-Based Spatial Clustering of Applications with Noise, and as the name suggests, it finds clusters in the data based on the density of the data. So let's see how it works. Uh, the parameter we are using in DBSCAN, the first one is the epsilon, which is the maximum radius of the core point, and we will talk about what is the core point. Here you can see the epsilon, which is the radius for a point. In this radius, I will look for points that are part of the cluster that can be generated by the point. If that point has enough, and the word enough is the mean points, if that point has enough points, namely at least mean points in its radius, the point is called a core point and a cluster starts. So epsilon defines the radius I will look at when evaluating a point. In this radius, I will look which points are with this point, and if there are enough points, namely at least mean points, in the radius of the point, I will call that point a core point, and I will start a cluster. So epsilon is the maximum distance between two points to be considered as neighbors, and mean points is the minimum number of points required to form a dense region, which is the number of points we need around a point to call it a core point. And now we'll talk about the core point. So a core point, here it is. To call a point a core point, what I need to do, I look at the point, I look how many points there are in radius epsilon around that point, and if the total number of points in that radius is at least the minimum number of points, like here is 3, here is 5, so I'll call that point a core point. Look at this point. I have 1, 2, 3 itself, 4, 5 points in that radius from the core point, and my mean point is 5, therefore I will call that point a core point. If I look at that point and I take a radius of epsilon around it, I will find only 1, 2, 3 points. Therefore, this point is not a core point. Yet, this point is in the radius of a core point. Therefore, this point is not a core point, but this point is in the radius of another core point. Therefore, I will call it a border point. And if I have a point and I look at the radius epsilon around that point, we decided what is the epsilon. And I find that there are no mean points in the radius epsilon of that point, and there is no core point in that radius from this point. So this point is not a core point. There are no mean points in the radius of epsilon around that point, and it's also not a border point because there is no core point in radius epsilon from that point. This is not a core point. You can check. Therefore, a point which is not a core point and not a border point is called a noise point. So this is a noise point. So we have a core point, a border point, and a noise point. Now, how we form a cluster? To form a cluster, what we are doing is looking here, we have mean points of 3, it's a little bit little, and a radius of epsilon. So to form a cluster, what we are doing is looking for core point. Here, this is a core point. We have mean points of 3. It has at least 3 points around it. Let's include itself. And so we started a cluster here. No, this is, I don't have another cluster. I want to show you this. Okay, I will show you how maybe I'll show you in a sec how it works to form cluster. And you saw how we form the cluster, but I want to show you how it gets bigger, this cluster. The idea is that if there is another core point in the radius of core point, so both clusters bunch together and we form another bigger cluster. And maybe I'll show you in a sec. DBSCAN algorithm. So here it is. That's good. That's good. Okay, so look at this. Let's open it in a new table. And maybe I want the, okay, this is great. No, please. Okay, look at it. I have here Q, which is a core point. We need to define the mean points in the epsilon, but let's consider it a core point. Let's try it with this. This is a core point. So I look at another point and I have another core point. So the cluster of this core point and the cluster of that core point are clustering together. Now I will look at that point. It's another clustering. It's another core point. So we have this cluster, and that cluster. So this core point and that core point, I can say that they are direct density reachable because this core point and that core point are in the radius epsilon of one another. Now I can get from this point to that point, from this core point to that core point, throughout this point. So I can say that this core point and that core point are density reachable. Okay, so the cluster itself in the end will be all these points will be clustered together. In the start, we will cluster that car cluster based on the core point. Then we will find that one of the points in the cluster created by that core point is another core point because it has enough instances. Let's say mean points is, I don't know, 5. So they are in the epsilon of another. Core point is the epsilon of another. So we adding up the clusters. And then we're looking at that one. Again, this point is in the epsilon radius of that point. This point is a core point. This point is a core point. So we are adding also them up and we are having a cluster built from all the points that are here. And that is the way we are expanding our cluster, starting with a core point and then another core point and then another core point. And if they are in the radius of epsilon from one another, we can add them up to form one cluster. Of course, it depends on one the mean points and epsilon we defined. So you can understand that this algorithm results are based on our decision of epsilon and mean points. And don't don't regard for this. I don't want you to regard for this. Okay. Maybe I will show you how different epsilons and different mean points can create different clusters. No, this is not one. No, this is not. But if you take different epsilon and different mean points, you will get different results. I'm sorry that I don't have here an example, but this is what happens. Oh, this is great. Yes. You can see here the idea that taking different epsilons, here it's epsilons, or so taking different epsilons get you different clustering result, as you can see here. This is with epsilon big 1, all of this is one cluster. With epsilon half, we have two clusters. We have till epsilon 0.33, we have three clusters. This seems the best, I think. With 0.25, we have this. And you can see that if we are taking the epsilon to be too low, it also becomes not very good because in something that look the same cluster, we have two clusters. So somewhere between, we have the best epsilon that create us maybe the best answer. And of course, we have noise points, as you can see here. We have noise points, we have core points, and we have border points. This is another great example of DBSCAN. We have the core points that are connected to one another and creating one big cluster, and the border points that are also part of the cluster. And we have noise points, which, if you look at the radius of epsilon of them, they are no core points, so they are part of no clustering, so they are called noise points. And the border points are not core points, but the radius contain core point. Okay, so let's continue. So we understood how DBSCAN work. We understood what is the epsilon, the radius, the mean points, the minimum number around a core point to create a cluster. And we understand what is the core point, which is the point in which epsilon around it there are at least minimum number of points, mean points, and a border point, a point that it's in its radius there is a core point, but it's not a core point, and a noise point, a point in which it's not a core point and not a border point. So how it works, we select a point, we start with some point P, we found all points density reachable. We saw what is density reachable from P with respect to epsilon mean points. Namely, I will look at the point and look epsilon around it, and I look which points are in the area. If P is a core point, the cluster is formed, as we said. If P is a border point, it's assigned to the cluster of the neighboring core point. If P is near there, it's labeled as noise and repeat all unvisited. Note, unvisited. Namely, if I already defined the point, I won't look at it again. So we can see here the difference between DBSCAN and k-means. You can see DBSCAN here, which does a very great job on this data and capturing the very unique structure of the data and the very unique clustering of the two uh, of the two of the two clusters. And as you can see, the k-means doesn't really capture the idea of the data. Namely, k-means say that I have here a cluster and I have there cluster, but the cluster are like the DBSCAN defines, more probably this is a cluster and there is another cluster. Here is the same, this is a cluster and this is another cluster probably, but k-means doesn't do a great job, and it splitting this cluster to two clusters, part of that cluster is here, not very good job. You can see also here how DBSCAN does quite a great job, and K-means does okay, but less good. It seems better here, maybe, I'm not sure. Here it look quite the same. Here it seems that it should be one cluster, and k means when you define k and you define the number of clusters, so you must say that if you define k for 3, so even though it looks like just one cluster, it is divided to 3. So you can see the advantages of DBSCAN, which can capture very unique structures of the data and cluster them accordingly. So DBSCAN is quite powerful. So you can see that DBSCAN, no need to specify the number of cluster. It is important. You saw it here. We didn't define. K means we must define. So we might do very bad things to the data. And DBSCAN just calculate the density, and by that defines uh, what is the cluster. You don't need to define how many cluster you want. You can find arbitrary shaped cluster, as we saw here, arbitrary shape, and robust to outliers. It identified the noises, as you can see here. I have noises, and it captured them quite. No, this is noise. It doesn't define it. This is not the best one. Maybe we need to look at another image, so you can see how it defines noise and it captures it, and you can use it for outlier detection, anomaly detection. Quite nice. Only requires two parameters that you define, epsilon and mean points. The limitation is struggle with cluster of varying densities. If I have, and this, here comes the optics clustering algorithm. If I have some, you define a epsilon and the mean points, which define what is the density of the cluster that you were going to do. You saw the different epsilons created different results, but if there are different clusters with different densities, so maybe your programmed constant epsilon and mean points are not very good for all the clusters because different clusters with different densities. So DBSCAN will have problem to catch that varying densities with different clusters, and it won't cluster it very good. Here comes again the optics clustering algorithm. Optics clustering algorithm, another density based, but it can find different density clusters. You can see here different density clusters. It found it. You see this is density, very lower density. This is high density. This is average. And DBSCAN very struggled with it and did it catch that this is another cluster. You can see barely here, but it defined it as, I don't know, noise probably, outliers, but this is not an outlier. It's just another cluster with a lower density. You can see that here. So DBSCAN is quite constant and it has its own limitations. Sensitive to choice of epsilon and mean points, as we saw, choosing different epsilons as choosing different mean points can give us quite different results. May have difficulty with high dimensional data. Okay, thank you. And this was about the DBSCAN density-based clustering algorithm, quite good algorithm, but it has its own limitation with the constant density definition. We are defining the epsilon, the radius, we are defining the mean points, we are defining the core points, the border points, and we get the noise points, and we do it, and we get the clustering, the density-based clustering, which is quite nice. Thank you very much. If there are any mistakes, please correct me. I'm not sure that I defined the word density reachable very good, but okay, whatever. The point is that you got the idea of DBSCAN clustering algorithm based on density with epsilon mean points. That's it. If there are any corrections, please correct me, and that's it.